Today we're going to talk about properties of operations. So we're continuing our conversation about, algebraic expressions and patterns and things like that, but something that's going to be really important for us is going to be to understand the properties that determine how we can work with numbers. So today we're mainly going to be focusing on how to identify the properties of operations and to determine if conjectures are true or false, and provide counter examples for false conjectures, and to use properties to simplify algebraic expressions. So let's get right into this. We're going to have a lot of properties we're going to have to take into our notes today. These are properties that we are going to have to work to remember, but the more you use them, the more second nature they become. So the first property is a property that you guys already know, the commutative property, which states that the order in which numbers are added or multiplied does not change the sum or the product. So we know the commutative property to be the property that tells us that I could do a plus b. That's the same thing as doing b plus a, or in other words, 6 plus 1 is going to give you the same answer as 1 plus 6. When it comes down to multiplication, again, a times b is going to give you the same thing as b times a, or in other words, 7 times 3 is 21, 3 times 7 is also 21, so 7 times 3 is the same thing as 3 times 7. So this is a property that we've already talked about a couple of times this year. Another property is the associative property. This is one we've talked about less this year, but it is something that you've probably seen in the past. The associative property states that the way in which numbers are grouped when they are added or multiplied does not change the sum or the product. Now this is so long as addition is the only operation that you see or multiplication is the only operation that you see, but when you see them in combination, then the associative property no longer works and you have to go back to your order of operations. The same is true with the commutative property. So the associative property states that if I'm adding three numbers, the order in which I group them does not matter. So if I want to add the second two numbers before I add them to the third, that's fine. If I want to add the first two numbers before I add them to the third, then that's fine as well. So in other words, if I'm looking at 2 plus 3 plus 8 and I want to add 3 plus 8 before I add it to 2, giving me 11 plus 2 is 13, that's fine. Or if I want to do 2 plus 3 before I add it to 8, that gives me 5 plus 8, which is also 13. Now looking at multiplication, the same is true. If I'm multiplying three numbers, a times the quantity b times c is going to be the same thing as the quantity a times b times c. Or in other words, if I'm trying to do 3 times 4 times 5, and I want to do 4 times 5 first to get 20, 20 times 3 is 60, I think that's easier than doing 3 times 4 is 12, 12 times 5 is 60. You can choose which order to group in. Now, we look at something that's called a counterexample. A counterexample is an example that shows that a conjecture is false. A conjecture can also be thought of as a rule or a statement. So if I say that the commutative property works for subtraction, that could be my conjecture, but I know that that's false, and the counterexample that I could use for that is, well, 5 minus 2 is not equal to 2 minus 5. I know that 5 minus 2 is 3, 2 minus 5 is negative 3. Those aren't equal. So there's my counterexample to prove that conjecture that I made false. Okay? Let's look at some more properties. Now, a reminder, a property is a statement that is true for any number, and here are some properties that are also true for any numbers. The additive identity is a property that states that when 0 is added to any number, the sum is that same number, thus the word identity. So we call 0 the additive identity because whenever I add it to anything, it brings back that same number's identity. So for example, a plus 0 is a, 0 plus a is a, 9 plus 0 is always 9, and then 0 plus 9 is 9, and you can do that with any number. You can add 0 to any number, you'll get the same number. We also have the multiplicative identity, and the multiplicative identity is 1, because when you multiply anything by 1, you get that same number. So we state that when any number is multiplied by 1, the product is the number. So we look at it in symbols or algebraically. A times 1 is A. 1 times A is A. That's the commutative property in action right there, and then right there and there as well. We have also in numbers, 5 times 1 is 5, 1 times 5 is 5. One more property that we're going to look at before we get into our examples is the multiplicative property of 0. And that states that when any number is multiplied by 0, the product is 0. And you can see your algebraic examples and your numerical examples. Okay? So let's get into some examples. Name the property that's shown by the statement. So let's look at this first one here. And this first one here, what do I see happening? Well, I do see grouping symbols. However, I don't see things being regrouped. I do not see numbers being regrouped. So automatically I think back to what could this be? It's either the associative or the commutative. But since the numbers are not being regrouped, then I'm looking at the commutative. Let's see. Well, yeah, I see one item or one term being multiplied by another, and then I see them being flip-flopped here. So this is the commutative property of multiplication. Alright, let's look at the next one here. I have 3m times 0 times 5m equals 0. So I look back into my rules and I notice that the one property that tells me that when something is multiplied by 0, the product is 0 is the multiplicative property of 0. So that must be the multiplicative property of 0. Alright, now let's look at the last one here. 7c plus 0 equals 7c. Now I see that I have a term being added to 0, giving me that same term again. So I see that this term retains its identity. So I go back and I look at the identities, and I was adding, so this must be the additive identity. So identifying the properties that are being shown by these statements, that's going to help you to remember the properties so that when you see them in action, you can pick them out easily, and then you can actually put them into action. Now, let's take a look at a counterexample problem. State whether the following conjecture is true or false. If it is false, provide a counterexample. So here's the conjecture. Subtraction of whole numbers is associative. So they're telling me to find out if that is true or false. And if it is false, I'm going to have to come up with a counterexample. So the first thing I'm going to do is I'm going to think of an example where I'm demonstrating the associative property and I'm seeing if it actually works or not. So let me think of some numbers. And these I'm coming up with off the top of my head. So you could come up with any numbers you wanted. So let's start. I'm going to start with numbers that are going to keep things positive, just so that I'm not working with more than one operation without realizing it, because if you put two negatives together, now you're working with addition technically. So I'm going to think of some numbers that are going to keep things positive. So I'm going to start with 24 minus 12 minus 3, and I'm going to group it as such. And I'm going to see, is that truly equal to 24 minus 12 minus 3? So associatively, let's see. 24 minus 12, that's 12 minus 3. 12 minus 3 we know is 9. Let's see. 24 minus, 12 minus 3 is 9. 24 minus 9, oh, that's 15. So these are not equal. So far this is false. Let's try some different numbers and see. Now at this point you want to pause because I'm about to erase these numbers. So if you haven't written these numbers down, you're going to want to pause. Alright, let's try some different numbers. 15 minus 12 minus 6. Is that the same thing if I group as 15 minus 12 minus 6, and let's group the 12 and the 6. 15 minus 12 is 3. 3 minus 6 is negative 3. 15 minus 12 minus 6, well, that's 6. 15 minus 6, that's 9. They're not equal. So it holds that this is false, and I can retain this as my counter example that shows that this conjecture is false. So anytime you're asked to prove if something is true or false, you're going to want to prove it using a counter example. Okay? All right. In a garden, a decorative pool in the shape of a box is 2 feet deep. So let's do this. 17 feet long. Let's draw this one. And 5 feet wide. So we're looking at a box, kind of like a Kleenex box, but much bigger because it's a pool. That's 2 feet deep by 17 feet long by 5 feet wide. Use mental math to find the volume of the water of the pool. The volume of the water in the pool. Well, we know to find volume. Volume is length times width times height for a rectangular prism, which is what we have here. So in this case, I'm looking at 2 times 17 times 5. Now they're asking me to use mental math. So using mental math, 2 times 17 I know is 34. 34 times 5 I might want scratch paper to do. However, if I use the commutative property and I switch those two numbers around, now I'm doing this in my head technically, but you can't see what's happening in my head, so this is why I'm writing it down. This is going to become 2 times 5 times 17. And whoa, look at that. 2 times 5 is 10. 10 times 17, that's 170. I can do that in my head because I know that anytime I multiply by 10, it just adds a 0 to the end of the number. So I know that this is going to be 170 cubic feet. So that's where the commutative property can come in handy because it can help you move the numbers around so that you can commute the numbers or associate the numbers in a way that allows you to more easily answer a problem without doing a lot of work. Okay? All right, one more example before we get to the problem of the day. And they're asking me to simplify 6 plus d plus 8, quantity d plus 8, and justify each step using properties. Okay, so I have 6 plus d plus 8. Now I know I cannot combine a letter with a number. I can't combine variables to numbers, but I can combine things that are alike. And we're going to learn more about this later on in this chapter, but we're going to go very basic with this lesson. So I know that I can combine the 6 and the 8. And I know that I have the properties that allow me to move things around. So I'm going to bring that I want to bring that variable out to the front. So the first thing I'm going to do is I'm going to commute this. So I'm going to say that this is the same thing as d plus 8 quantity plus 6. I'm going to justify that step using the commutative property of addition. Then I'm going to use the associative property of addition to say that that's the same thing as d plus the quantity 8 plus 6. And I'm going to justify that again using the associative property of addition. I'm going to wrap things up with, well, now I know what the final answer is. It's going to be d plus 14, and I can't add anything else. And there's my justification. I've used the associative property and the commutative property. Okay? So let's get into that problem of the day. Here I just want you to name the properties used in each statement, and we'll go over this first thing in class tomorrow. Have a great night.